All right, so let's talk about a problem from the homework that, and I'm going to do a version of that here. And so let's suppose that Santa has to deliver 10 presents to kids, but he screwed up and he somehow, while putting labels on the presents, only got 3 of the labels right. So we want to know how many different ways could this have happened? Well, in order to solve this, we need to think about what are the various pieces of this that are going on at this moment. And so there's 2 things happening here. One, Santa did get 3 of the labels right, and so that's something we need to address. And then Santa got every one of the remaining labels wrong. And so these are both happening at the same time, which invokes the principle of multiplication. So when we want to think about what's happening here, what we need to think about is uh, its number weighs 3 right, times number weighs 7 wrong, right? That's the, and we take the product of those things because they're happening at the same time, and so we need to count these 2 things separately. Now, picking 3 right, or getting 3 labels right, is just a matter of taking our set of 10 elements, or 10 presents, and picking 3 of them at random. I don't know, 3, 6, 7. Those are the labels that he gets right. And so the question is, how many different ways could we have done this? Well, there's 10 elements. We're picking 3, and the order in which he gets them right does not matter at all. And so we should see that there are 10 choose 3 ways to count the 7 that are right. And now the 7 wrong that remains, these 7 elements, they have to be rearranged, and they have to be rearranged in such a way that none of them get their own present back. So this is itself a derangement, and specifically it's a derangement on 7 elements, and will always be a derangement on 7 elements no matter which 3 of these we choose to get their correct label. So when we're looking at the derangements aspect of this, we go back to the identity for derangements on 7 elements, and we note that that is a sum from k going to 0, up to 7 minus 1 to the k, 7 factorial over k factorial. Now, that might be sufficient to actually solve this problem if you put it into infinity in the right way, but let's just go ahead and take a look at what this number might be. So I'm going to call this bad. Bad stands for, of course, Santa being bad and not getting the labels right. So we're summing from k equals 0, let's say up until n, some number of ways, and that goes from minus 1 to the k times n factorial over k factorial. This is, of course, our identity for derangements in general on n set. And if we have 7 elements, then that is the number of derangements on 7 elements, 1,854 possible derangements. And so our goal then is to take 10 choose 3, which is 120, times the number of these derangements, bad, which gives me 222,480 ways. And so that will then be the total number of ways that Santa could have done this particular screw up, getting exactly 3 of the labels right and getting the other 7 wrong. All right. Uh, Thank you very much. And as usual, please let me know if you have any questions.